Hi friends, right now I'm going to go over with you how to solve two-step equations. We practiced this a little bit, mainly with word problems, so we're going to really get into the procedure. So we just have three simple steps here, okay? Identify the operations happening in the problem, apply the inverse operations to isolate the variable, check your solution and sign. Some of these do mean, though, that there might be two parts of that step. So if there's more than one operation happening, that means we have to do two inverse operations, which is where this two step comes from. Okay, and I'm just gonna make sure I have a pencil ready to go. So those are my steps. Whoop. So I have this part right here, 2m plus 5 equals 29. And actually, I'm gonna scooch this up because I wanna be able to see the steps first, okay? So we know this though, that I like to put a line through the equal sign. It really just helps me visually. So I'm going to start with that, even though it's not technically in our steps. But the next part that is in our steps, identify the operations happening in the problem. So I have 2m plus 5 equals 29. I put the line through the equal sign because that's separating the two expressions. So 2m is multiplication. Plus 5, that's addition. Okay, so I did the first step. Yay! Now I need to apply inverse operations to isolate the variable. And remember that inverse just means the opposite. So I'm going to have to do the opposite of multiplication and the opposite of addition. But order is important here. So we're actually going to take the normal PEMDAS, the way that I would have solved the problem, but remember that I'm going backwards. I'm undoing it. I'm starting with addition and subtraction first. Okay, so the opposite of adding 5 is subtracting 5 from both sides. 5 minus 5, that makes 0. So I bring my 2m down, and 29 subtract 5, that's 24. And so now I can do the inverse operation of multiplication. Divide by 2, divide by 2. So m equals, and I'm doing that because this is a 1. 2 divided by 2 equals 1. That's why now m is totally isolated. And 24 divided by 2, that's 12. So the answer to this problem is m equals 12. And now I did my inverse operations. I can check my solution. So that means I'm doing 2 times 12 plus 5 to see if I'll get 29. Well, 2 times 12 is 24, and 24 plus 5 does in fact equal 29. I'm undoing the problem, so I'm going to do another one. Okay, put my line through the equal sign. Come on, there it goes. And I'm going to identify the operations happening. So it does say -3, but it still is a number right next to a variable. So that's still multiplication, even though it's a negative. I can multiply by negative numbers. So this is multiplication. And so -3x minus 8. All right, that's subtraction. Sweet, just like last time, I'm going to start with addition and subtraction. So I'm doing the inverse of subtraction this time, adding 8 to both sides. That made 0. And now I have negative, don't drop your negative, -3x equals 7 plus 8 is 15. Okay, now I'm doing the inverse of multiplication, which is division. And I'm going to divide, come on, by a -3. Whatever I do to one side, I do it to the other. And remember, this gives me 1. The whole thing is I'm trying to isolate my variable, get it all by itself, but it does still have to exist. That's why I made a 0 first, and now I made a 1, and x equals, well, 15 divided by negative 3, there's only one negative, so the answer is negative. 15 divided by 3 is 5, negative 5. And then I can check this too by substituting negative 5 in for x. So negative 3 times negative 5 minus 8. I want to see if that'll give me 7. So negative 3 times negative 5 is positive 15, because a negative times a negative is a positive. And 15 minus 8 does in fact equal 7. So that one's correct. Ooh. I got a couple more examples I'm going to do for you, and then we're done. All right. This one, and I wanted to make sure to do an example this way because it's written a little funky, but we still sometimes get problems like this. So it says 7 minus 6h. So a lot of you are going to tell me I have subtraction and multiplication. But even though it says minus 6h, that negative 6 is still being multiplied by h, and that 7 is not being subtracted. If I were to put a 0 in front of it, that would be 0 plus 7. It's a positive number. The only way to make it 0 would be to do the negative. So this is actually over here, because it's a positive amount, addition. The 7 is being added because it's a positive number. That 6 is being subtracted. So that's where the negative is. So be careful with that. That's a common mistake. So I need to subtract 7 from both sides. 7 minus 7 gives me 0. Don't drop that negative. Negative 6h equals negative 17 and another negative 7. That gives me negative 24. Oh, yeah, that's correct. Okay, now, because I'm doing the inverse of multiplication, I'm going to divide by negative 6 because I have to make it become a positive 1. Divide by negative 6. And look, negative 6 divided by negative 6 gives me a 1. So the answer is h equals a negative divided by a negative is a positive. 6 can go into 24 3 times? No, this is totally 4 times. Goober. And again, I can always check it. So I would be doing 7 minus 6 times 4. Do my multiplication first to get that it's 7 minus 24, and 7 minus 24 does equal negative 17. That's how I check these. And then one last example, because all of those were multiplication. I wanted you to see a division one, because they happen. They're just not as common. So you guessed it, it's division. When we have a fraction bar, j over 6, that means division. And we have addition. So now that I know my operations, I can apply the inverse. So the opposite of adding 4 is subtracting 4. That made 0, so I'm going to bring j over 6 down and get 16 minus 4, that's 12. And don't let this trick you. Some of you right now are probably looking at that 12 and that 16, and you're going, 12 divided by 6, this equals 2. But 2 divided by 6 is not 12. That's why we've got to make sure we're applying the inverse operations. It says division, so we need to multiply by 6. And again, that still makes a 1 because they divided by 6. Oh, dang it, I had it. They divided by 6, so we multiplied by 6. 6 divided by 6 is 1. And we get that j actually equals 72, right? Yeah, because 6 times 11 is 66. Yep, 72. And then when I substitute it in over here, 72 divided by 6 plus 4. Well, 72 divided by 6 is 12. 12 plus 4 is 16. That's how you solve those two-step equations. And as always, let me know if you have any questions. Bye, friends.